Okay, today we'll be working on 6-7 exponential and logarithmic inequalities. So there are two things that we're going to be looking at. First of all, I'm going to start with the exponential, then I'm going to move on to the logarithmic. So what would be the first step in solving each one of them? Now before we answer that question, let's remember, every time we have an exponential function, what can x be? What is the domain of exponential functions? The domain is going to be from negative infinity to infinity. So that's why we don't have any special considerations. We don't have any of that because x can be any number. So there's no special consideration because the domain can be any number. Oh, how about just writing none? Much simpler. Okay, none. Okay, now what would be the first step in solving each one of them? Now, to be able to solve exponential, the first step is always to use log. So ask yourself, the power, which is 2x minus 1, is equal to log base 8 of 15, and you move that down the smaller equal. So now since x is on this side, the x has to stay on this side and you move on the inequality sign. Okay, so 8 to the power 2x minus 1 is equal to 15, so I would just write it down if I were you without a inequality. And every time we have an exponential, the first thing that you should do is change it to log to solve. So log base 8 of 15 is equal to 2x minus 1. So that's how you change it, right? But since the x in your inequality is on this side, make sure to put the 2x minus 1 on the same side. Smaller equal, so you copy down the inequality as it is, you don't shift it, and equal to the other side, which is log 15 base 8. You got it? So if x on this side, x stays on this side. Now, what you can do is you can find log 15 base 8 on your calculator by going to math and then to log base. So math, you go down to log base, or you can go up twice, and then you put 8 and 15. This is one way. Okay, so 2x minus 1 is smaller or equal to 1 point, always rounded to the third decimal number, and then you add 1 to both sides. You get 2x smaller or equal to 2.302. You divide both sides by 2, so x is going to be smaller or equal to 1.51, and that's going to be my solution. That's it. This is how you do inequalities. Now the only thing that I want you to pay attention to is that since we divided by a positive number, the inequality did not change. It's always facing this way. X smaller or equal to 1.51. Every time you multiply or divide by a negative number, this is when you have to think of the changing the or shifting the inequality sign. So this is one way of solving it. Is there another way? Yes. But let's think of this way first. I think it's easier. We'll talk more in class about the second way. Now let's just focus on this method in the video. Now, to make sure that you understand this, we're going to do one more. So I want you to pause the video and try to do, let's say, maybe number 2 on your own. So go ahead, try number 2 on your own. Pause the video, try it. Go ahead. I hope you did. Now if you did pause the video and you did it on your own, you're going to see that your answer is x greater than negative 0.315. If you got this answer, just scroll down the video to where the log is, or if you want, you can pay attention. Now since this is an e, then to change it to ln, so I'm going to put e to the power negative 9x is equal to 17. I'm going to set it equal to try to check what my equation is, if it makes you feel more comfortable. Now ln of 17 is equal to negative 9x. That's how you change it. But since my x is over here, I have to put the x side on this side. So negative 9x smaller than ln 17. You see that? Now ln 17 on the calculator is going to be 2.8 2.833. So negative 9x is smaller than 2.833. You divide by negative 9. Now, since you divided by negative 9, this is when you shift the inequality and becomes the other side, because you are dividing by a negative number. So x would be greater than negative 0.315. So I hope you got this answer. Now the next step that we're going to be doing together is to check whether our answer is right or wrong. Now, for my pre-AP, how can you check this? Take any number that's greater than negative 0.315. I think 0 is the number, so I'm going to try 0. If x is equal 0, e to the power negative 9 times 0 smaller than 17. So what I did is I'm plugging it in to make sure that it makes sense. E to the power negative 9 times 0 is just a 0. E to the power 0 is 1. And I got that. So yes, my inequality is right. So make sure that you check your answer. Now, or you can just check on the calculator. You can go to y. You can put e to the power negative 9x. So you can put e to the power negative 9x. So you put the first one on y1, and the second part you put it on 17. And then you go to second table, and let's see for what x values. Now I'm saying that x has to be like somewhere greater than negative 0.3. So let's see. Like negative 1, as you can see, it's much bigger. So greater than negative, it means it has to be 0, 1, 2, 3, and so on. So on 0 we have 1, 17. Good. So it does work on the equation because y1 has to be less than 17. So for what x values is this right? Like y1 is less than 17. So in 0 we have 1 less than 17, we have this less than 17. So any value from 0 and up would make sense. And since I'm saying x is greater, it means it has to be up or greater than a 0. So yes, it does make sense. Another way for you to check, instead of plugging it in, like take a number greater than negative 0.315, which is a 0. And if you check on your calculator, you see that e1, or e to the power negative 9x, is 1, which is less than 17 because you want it to be less. So yes, it does make sense. So always you can go back to the calculator to check. Now, I hope that was helpful. Now let's move on to how can we solve every time we have a log. Now here you have to pay attention. Do we have special consideration? Yes, because log can only be positive on the inside. You cannot have log of a negative. You cannot have log of a 0. So the inside of the log should always be positive. So the x minus 5 should be greater than 0. This is the first thing that you should do. This is your special consideration. So you add 5 to both sides. It means that x should be greater than 5. You do that for the log because log can never be having a negative on the inside. Now, the second thing you should do is that take the log base 4 of x minus 5 smaller than 3. So the first thing you should do is take the inside of the log, set it greater than 0, because the log should be always positive, and then take the actual inequality and solve that. Again, the same method. In order to change to solve a log, you have to change it to exponential. So I'm gonna, instead of the inequality sign, I'm gonna put equal sign because I feel more comfortable doing that. Now remember, use the circle method. So 4 to the power 3 is equal to x minus 5, and this is how you change it to exponential. Now remember that here's your x, so whatever x is, it should be on this side. So x minus 5. X minus 5 should be smaller than, and what did you get? 4 to the power 3, and it should be on this side. 4 to the power 3. So first of all, change it to equation, try to solve it, change it to exponential function. Then what you need to do, make sure that this is on this side and the 4 to the power 3 on this side, so you don't change the inequality. So x minus 5 is smaller than 4 to the power 3, which is a 64. So x minus 5 should be smaller than a 64. Add a 5, so x should be smaller than 64 plus 5, which is a 69. So as you can see from number 1 and 2, I have two answers. Every time I have two answers, you have to put them on a number line. So x greater than 5 and x is smaller than 69. So this is your 5 and this is your 69. Greater than 5, circle and you take a line above it. Smaller than 69, it means a circle and below it. And then you check where the two lines meet. As you can see, the two lines meet over here. Then your answer is going to be between those two. So that's going to be your final answer. So every time you have a log, you have to be careful and you have to make sure that you take your special consideration and you solve the inside of the log to be greater than 0, and then you solve the actual inequality. Now I want you to pause the video and try to do one on the back sheet. So let's try number 5. So go ahead and try number 5 on your own. Now, is there another way to solve this? Yes, definitely. We'll talk more about the second way in class, but I want to focus on one method in the video. Now, remember, this is a log, so the inside of the log should always be positive. So the inside of the log is 2 minus x, so 2 minus x has to be greater than 0. You subtract 2 to both sides, so negative x has to be greater than negative 2. Then you divide by a negative. Because you divided by a negative, this has to flip. So x is going to be smaller than positive 2. So that's the first answer. So the first answer, you get it from the inside of your log. Now, what you need to do is take the actual one, set it equal to 3, and try to solve it. So do the thing. So 2 minus x should be equal to 6 to the power 3. Or 6 to the power 3 equals to 2 minus x. Now since the x is on this side, so I'm going to start by putting the x1 on this side, and then smaller or equal to 6 to the power 3. So since x is on this side, the x has to be on the left side. Remember that. Now 6 to the power 3 would be, do it on the calculator, would be 216. So 2 minus x would be 216. Minus 2 minus 2, so negative x is going to be smaller or equal to 14. Now remember, you have to isolate x or only find x. Since you are dividing by a negative, so x has to be greater or equal to 214, so that's going to be your second answer. Since we have two answers, did I make a mistake? Yeah, because 214 divided by a negative number would be a negative 214. So now let's move on. Since we have two answers, x smaller than 2 and x greater or equal to negative 214, we have to put that on the number line. So that's going to be a negative 214. So you put them in order. X is smaller than 2, so you start with 2 and you go lower. X greater than negative 214, so you start over here and you have to make it solid and you go up. Now your answer is going to be wherever those two meet. So it's going to be, x is going to be between negative 214. For some reason, it's always those examples that we are doing, it's between, but it's not always this case. So make sure that you solve it and see where the two lines meet. Now this can be, so you put greater or equal. Now to check if your answer makes sense, take a number between negative 214 and 2. I'm going to take 0. So that's going to be my testing point, and I'm going to plug it in the equation, which is log base 6 of 2 minus x, and I'm going to check if it's going to give me a 3. So you can do that on your calculator. You can do log. I'm going to go to math, go up twice to log base. What did I do? Okay, quit and then do it again. Math, go up twice to log base, and on the base we have a 6, and over here we have 2 minus, and we decided to put the x to be 0, so 2 minus 0 is 2, or you can just put 2 minus 0 if you want to do that. Press enter and gives you 0.386, so 386 is smaller or equal to 3, and yes, that's true. So your answer is